All right, solubility curves. To begin this lesson, I want you to think about uh, the perfect hot cocoa drink. The perfect hot cocoa drink will be at the right temperature. It will have the perfect amount of cocoa solute in there to where it's not too sweet or not too unsweet, I guess you can say. And even when you finish drinking it, there will be no cocoa powder mix at the bottom. I'm sure some of you have definitely drank hot cocoa to where you will still see hot cocoa powder at the bottom. I'm sure you guys have drank hot cocoa to where it was more diluted. It didn't have enough hot cocoa in there and it tasted more watered down. But in the perfect hot cocoa drink, um, it will not be diluted. It'll be the perfect amount of sweetness and there will be no hot cocoa mix left at the bottom of this drink. Temperature plays a part in when you're making your hot cocoa because if you've ever had to dissolve hot cocoa in a cold drink, it can be quite tough. It doesn't necessarily dissolve very easily unless you increase the temperature of the water, and then the hot cocoa mix dissolves much faster and much quicker. So temperature plays a part in solubilities of solutions out here. So now keep this hot cocoa kind of in mind because when we talk about solubility curves, it kind of helps give you a visual of some of these things. So this is what we call a solubility curve. This solubility curve, it has a measure of temperature because temperature does affect solubility. And we also have a measure of solubility in how many grams of solute in 100 grams of water. So if I had 100 grams of beaker here, how much can I dissolve in this beaker to where it'll be perfect? Yeah, I don't. It'll be perfectly saturated. So there'll be no powder at the bottom. It'll be perfect amount. Now we base this off 100 grams of water. Now, so here's 20, 40, so on and so forth. It goes in grams. On this chart, we see several different types of salts. Compounds, so potassium nitrate, sodium nitrate, potassium bromide, ammonium chloride, sodium chloride, and ytterbium sulfate, an interesting one. So in this graph, it helps us determine how much we can dissolve perfectly at a certain amount of temperature and a certain amount of solute per 100 grams of solvent. Okay, this graph does show different types of salts out here. So now, interestingly enough, some of these salts have different properties. Some salts dissolve very easily when you increase the temperature. So if you look at potassium nitrate, you can dissolve quite a lot of potassium nitrate at much higher temperatures than you would at lower temperatures. And that's why you have a very increasing curve over here, positive slope. Your normal table salt that you put, that you're probably the most familiar with, that actually doesn't matter what temperature it is. You keep your temperature around, it's around 38 degrees Celsius. Sorry, about 38 grams. Sorry. You can dissolve table salt whether it's cold water or hot water. It does not really matter about the temperature of the water. So that's an interesting property of table salt that you may not be aware of. Whether it's hot water or cold water, it'll still dissolve the same amount. Now, not every compound dissolves more when you can heat it up. This compound here, ytterbium, which I can never pronounce correctly, sulfate, actually gets worse when you increase the temperature. You increase the temperature of your liquid, and it actually dissolves out less. According to this graph, I can only dissolve at 80 degrees Celsius. I can dissolve about 10 grams of it. Whereas if it was colder, I can dissolve about 40 grams at 10 degrees Celsius. So not every compound you can dissolve more when you increase the temperature. Okay, so some of the best ways to kind of understand solubility curves is to answer some questions. So question number one, what happens to the solubility of potassium nitrate as the temperature increases? So we're looking at one specific salt, in this case, potassium nitrate right here. Whoops, change it to a different color. So we're only looking at the purple one here. And basically the trend is that as you increase temperature, you can dissolve more. Your solubility increases. It's interesting with potassium nitrate is you can actually dissolve more solute than you have of a solvent. So at this point right here, I can dissolve 140 grams of it in 100 grams of water. That's a very interesting property of potassium nitrate. You can dissolve more solute than you actually have of solvent. Normally, in things you interact with, it's the opposite. You usually dissolve less solute in a solvent, but here, more solute in a solvent. But again, in colder temperatures, it's the opposite. At 10 degrees Celsius, you can only dissolve 20 grams of it in 100 grams of water, but at a higher temperature, you can dissolve more. So uh, solubility increases as the temperature increases with potassium nitrate. Okay, question number 2. Erase this really quick. Which substance shows a decrease in solubility as temperature increases? And there's only one on this chart that we are seeing here. Again, there's millions of chemicals out there. They each have their solubility curves out there. We're only seeing, what, 5 or 6 of them. So um, you pick YB2SO43 actually has a decrease in solubility as temperature increases. So you cannot dissolve as much in hot liquid than you can in a cold liquid. Okay, question number 3. Which substance shows the most change in solubility? Most change is that you're basically having a much, your curve is going much higher. So in this case, for question number 3, it'll be potassium nitrate. That line increases pretty fast as temperature increases. On the opposite end, which substance shows the least change? That's going to be your household table salt. Hot water, cold water, you can dissolve about 38 grams of table salt in 100 grams of water, whether it's hot or cold. All right, next question. How many grams of potassium nitrate can you dissolve in 100 grams of water? Okay, so at 10 degrees Celsius. So at 10 degrees Celsius, I'm looking at a very specific temperature here, and I'm looking at only at this vertical line here. So I'm kind of stuck on this line. I'm looking at potassium nitrate, so I'm looking at the purple line, and I can dissolve, the maximum I can dissolve is 20 grams of it. Now, the line, each line, when you're on the line, that means you are saturated. That is the maximum amount you can dissolve at that temperature. If you are below the line, then you are unsaturated, which means that you can actually dissolve more. So since I'm on the line at 10 degrees Celsius, the maximum amount I can dissolve is 20 grams. And what this means is when you put this in water, you will not see any powder at the bottom of that solution. It will be perfect. And if you try to add a little bit more, it'll just sink to the bottom. It will not dissolve. I mean, something you can do at home is try with table salt. Put some table salt in water, watch it dissolve. You put in half the can. The rest of it is just going to sink to the bottom, and you're going to have this mushy, powdery stuff at the bottom. So there's only a maximum amount of table salt you can dissolve at a certain temperature out there. All right. Okay, number 6. If you dissolve 80 grams, whoops, let me erase this really quick. Okay, it says here, if I can dissolve 80 grams of sodium nitrate in 100 grams of water at 30 degrees Celsius. So I got to stay at the 30 degrees here. And I dissolve 80 grams. I'm right here. And I'm looking at sodium nitrate. So the red one is a solution saturated or unsaturated. So if you are end up on the line, you are saturated. So this is the saturation point. This is the maximum amount you can dissolve. Since I'm below the line, I can actually dissolve more. So since I'm below the line, I am what we call unsaturated. I can still add more solute to get it to be saturated, which is roughly about 10 more if I would predict, guesstimate. About 10 more grams, I can get to the saturation point. But as of right now, question number 6 is I'm currently unsaturated. Okay, question number 7. You have 60 grams of KBR. So I'm only looking at the green one, KBR. I have 60 grams, so there's some 60 mark at 40 degrees Celsius. So here I'm at. So I crossed my temperature with my amount of solute I was dissolved. How much more can you add for it to become saturated? So I am currently unsaturated. I can add more. Right now I'm at 60. Right now the saturation point is about 80. So it looks like I can dissolve about 20 more grams. So I can add 20 more grams of solute to this in order for this to become saturated. Okay, question number 8. I want to dissolve 140 grams of sodium nitrate in 100 grams of water. So I'm looking at NaNO3. If I dissolve 140, at 70 degrees Celsius. So I'm right here. So I'm actually above the line. I'm looking at the red line for sodium nitrate. I'm above the line. And so my saturation point is 70 grams. Sorry, 120 grams. Sorry, 120. So I could dissolve 120 at 70 degrees Celsius, but I put in 140. Well, what does that mean? That means 140 minus 120, and that's about 20 grams there. That's how much will not dissolve. So if you get a beaker of this stuff and you put in 140 of it, you're going to have 20 grams sink to the bottom of that beaker. So 20 grams is how much will not dissolve in that beaker out there. So that's what that means. If you go over the line, uh, however, how high you go over the line will determine how much will not dissolve and will just simply sink to the bottom of that beaker. All right, question number 8. No, did that already. All right, so last question. The last question has to do a little bit of math, and it's a ratio. It says here, if I could dissolve 60 grams of KBr in 100 grams of water, so I'm looking at KBr, I got 60 grams and 100 grams, 60 grams, 100 grams at 10 degrees Celsius. So here I'm saturated. So if I could dissolve 60 grams of KBr in 100 grams of water at 10 degrees Celsius, how much can I dissolve in 350 grams of water? Okay, so this whole graph is based off 100 grams of water. The minute you start mixing in different amounts of solvent, you're going to have to do a ratio. And the ratio is this. So if I could dissolve 60 grams of KBr in 100 grams of water, and I'm getting this 100 grams of water from right here. It's always the grams of your solute, which is a G over here, divided by 100 grams of water. So I can dissolve 60 grams of my solute in 100 grams of water. It's a ratio. They want to know is how much you can dissolve in 350 grams of water. So it's going to be X grams of KBr over 350 grams of water. So whenever you do not have 100 grams of water or some other amount, you're going to have to do this ratio. So for every 60 grams of water over 100 grams of water equals the X amount of solute, which in this case is KBr, over 350 grams of water. Now I'm going to do a little cross multiplying here to solve this. 60 times 350 times 100x. So I hope I have enough board space here left. So 60 times 350 cross multiply equals 100x. It's not letting me erase this. Try and write smaller. So 60 times 350 equals 100x. Well, I got to solve for that x. So 60 times 350 divided by 100, you plug in your calculator, and you will get 200 grams of H2O. All right, there you go. Hope that helps.